Let us continue our discussion of instruction hazards topic from the subject computer organization. We had seen instruction hazards, and today we'll be continuing the discussion of instruction hazards with mitigation technique called as delayed branching. So last time we had seen what exactly is a pipeline stall. It is also called as hazard. Pipeline stall causes because of cache miss. Pipeline stall may also cause because of branch instructions. We introduced one keyword called as branch penalty. Branch penalty was time lost because of pipeline stalling, because of branch instructions. Now, the technique we mentioned for reducing branch penalty was computation, earlier computation of the branch address. These were the topics which we had seen last time, and you can see here I2 is a branch instruction, and there are two slots here, post branch. Then I2 is a branch instruction. There is one slot post branch. Then we had mentioned the use of instruction queue and prefetching technique to reduce pipeline stall. And we had also introduced a term called as branch folding. So, what was the branch folding? Branch folding was concurrent execution of branch instruction with along with other instructions, wherein we had mentioned this diagram and we said that I1, I2, I3, I4, IK, all these will be executed in the sequence. Today's focus of discussion is conditional branches. We know that conditional branches also introduce hazards as there is a dependency of branch condition on the result of preceding instruction. Branch instructions represent nearly 20% of dynamic instruction count of the programs. So, what is dynamic instruction count? If there is a loop, say for 100 times, so those 100 iterations are also counted. So, instructions, executions, and their count, including the looped ones. So, that is called as the dynamic instruction count. So this will also introduce hazard. So to overcome this hazard, one technique mentioned is delayed branching technique. Now we had just introduced a branch delay slot. Let me show it again. Here you see the branch delay slots. There are two slots here immediately after the branch. And here immediately after the branch there is a one branch delay slot. A technique called as delayed branching can minimize the penalty incurred because of conditional branching. So we need to understand what exactly is delayed branching, as delayed branching is a mitigation technique which overcomes pipeline stall because of conditional branches. So let us look at this program instructions, and let us compare the original program loop in A with the reordered instruction with B. Let us see what this has. Uh, we are using R2 register as a counter. R2 is a counter which goes on decrementing, and this counter is used to shift left register R1 contents, to shift left register R1 content. Now, Here there is a branch condition. So depending on the branch condition, whether it is true or false, it will either go to loop back again and do the same thing, or go to the next and does the addition of R1 and R3. This is our original program loop and the instructions therein. So what we see here is the same instructions are reordered in part B. If you compare A with B, what we are seeing here, we have this shift left. We have brought below the branch. We have brought below the branch. That you need to remember. That you need to remember. Now, what we are saying here, the instructions are reordered. So in delayed branching technique, what happens is instructions are reordered. In this example, we are saying the instructions are reordered. And shift instruction, as you can see here, shift instruction is fetched. Shift instruction is fetched while the branch instruction is being executed. See here, the branch instruction is being executed and the shift instruction is being fetched. Okay, so once whatever the branch condition is evaluated, one of the either loop will be selected or next will be selected depending on what the branch condition is, whether it is true or false. So in both the cases the shift is executed. The shift is executed. Now, logically, what will happen is the program is executed as if the branch instructions are placed after the shift instructions. Okay, the branch instructions are placed after the shift instructions. See here, here the branch is placed after shift, but we have reordered because we want to overcome pipeline stall. Still, logically, what will happen? The same result will happen as if the branch is after the shift. So branching takes place one instruction later than where the branch instruction appear in the memory. Hence, this is called as delayed branching. So this was a short video